Hey, what's up everyone? Just wanted to start with this slide that we ended with when we talked about monsoons. So remember that the monsoon climate is that of a sharp or a distinct change in wind pattern, which oftentimes can lead to a really dry climate for one season and a really dry climate for another season. So I just wanted to remind us of what we saw with the city of Mumbai, India. And on this graph here, is what we would see in terms of temperature variation. So there's not a whole lot of variation here, right? Which is the blue columns, which is on our left y-axis. And then our rain here is on the right y-axis in inches. So we can see that there is not a whole lot of change in temperature, but there is certainly a pretty distinct change in rain, where we have a very distinct dry period and a very distinct wet period. What I want to point out most specifically is that the wet period has, for the month of July, on average, they get 30 inches of rain for the whole month of July. Again, for perspective, San Francisco gets about 21 inches of rain in a whole year. So they get more rain in 1 month than we get in a whole year. So it's pretty wild. So in terms of the impacts for India, overall, I mean, like flooding is the #1 meteorological killer. No question. Like water is super powerful. We've seen impacts of this throughout the semester. But monsoonal flooding in this area is pretty common. And with the idea of climate change, unfortunately, monsoons in South Asia are expected to worsen. It's not necessarily that the frequency is expected to increase, but the intensity of these storms is expected to increase. So a lot more water deliverance in shorter spurts, and maybe even in different months, in different seasons, which is very concerning. But India is not the only place that observes monsoonal climates. We can also focus over here on the Sahel and the Sahara Desert, so regions of Africa. So we have the Sahel rainforests, and the Congo rainforests, which kind of exist in this little band here, and then we have the Sahara Desert just above it. So also, if we recall, monsoons happen with the shift of the ITCZ, or the Intertropical Convergence Zone. So in January, the ITCZ is shifted a little bit more south, whereas in July, the ITCZ is shifted more northwards. So there's an influx of moisture further north, basically. And there's tons of different impacts of this. You could think of nature, where like if you have this really deserty region here in the northern Sahel, if you have an influx of water that can bring wildlife. There's various episodes, desert episodes of like Our Planet Earth and Our Planet, things like that. David Attenborough narration stuff, where creatures make huge migrations to hopefully find water because of this monsoonal flooding or monsoonal season here. It can also have some impacts on tropical cyclone development and sustainment, by the way, because we have storms that pop off of through the ITCZ off of the Sahara Desert or off of Africa. So I wanted to do a similar analysis for somewhere in Africa. So I chose a place called Niamey, Niger. I may be saying that incorrect, but it's located here on like the south western corner of Niger. Once again, we can see that the temperature stays relatively moderate. It maybe even seems like there's a little bit more variation in temperature, but we can still definitely see a high rain like influx or like peak, and a region of no rain, right? But paying attention again to our axes variables or values, it's not nearly as intense as Mumbai. We also see this phenomenon here in the North American coastlines or areas in Arizona. So this was something that was really awesome when I lived down in Tucson. One of my professors here would always say the monsoon, like literally put it in quotes because he didn't want to believe or say that it was actually a monsoon, but it turns out it was, because it's still a wind shift, and this wind shift can bring moisture from the Pacific Ocean into the southwest US, and it can produce these really intense storms, just like the other regions of the world we've already discussed. And so I did a similar analysis for Tucson, Arizona. So Tucson's right down yonder. And you can see now that it's maybe not as like stark of a dry period and a wet period, but we can definitely see that there is a more pronounced wet period. But once again, looking at the value of our right y-axis here is not nearly as large as our friends in India or Nigeria. But the temperature also is much more fluctual as well. So moving on from monsoons, there's this idea of ENSO, or El Nino Southern Oscillation. So this is just another sort of oscillation or pattern that we observe throughout the earth, in Earth. So if you've never heard of El Nino or La Nina before and you speak Spanish, I say shame on you, because these are words from Spanish, with El Nino meaning the boy and La Nina meaning the girl. But we're talking about them now in terms of the atmosphere. So with El Nino, we would observe anomalous warm waters near the central equatorial Pacific, which are driven by wind patterns. We know this idea that wind moves water. We've observed that several times in our hurricane analyses this semester. So the weaker winds means less water movement, frankly. And so these shift in sea surface temperatures, SST stands for sea surface temperatures, by the way, shifts these weather patterns with implications all over the world. And it's kind of wild, actually. So ENSO is a combination of sea surface temperatures as well as pressure differences. So overall, it's this really beautiful symbiotic relationship between pressure differences in the atmosphere and wind differences alongside the ocean. So the atmosphere influences the ocean influences the atmosphere. It's a really beautiful thing. So the opposite of El Nino is La Nina, meaning that there's anomalous colder waters in the central equatorial Pacific. There is like a specific region that we consider when we're looking at these values. So this would be what normal conditions look like, and we're focusing down here on South America because the implications in South America are much greater than other regions. So basically this surface high right off the coast of South America, and if we remember, in the southern hemisphere, the highs rotate counterclockwise. And so this pushing of water towards the north literally moves water out of the way. So when you move water out of the way, you have to replace it with something else. And so that replacement of water is a process called upwelling. And that water comes from the deep. It's super nutrient rich. And it allows for plankton in the area to get really excited and get like, oh my God, I love food. Thank you so much. And the plankton blooms encourage little fish to come, and then the little fish encourage big fish to come. And then humans are like, holy bananas, I love big fish. And so it's really, really great for local fishermen and the local economy. But if we were to consider when El Nino happens, then this process slows down to a crawl, if not stops. And so this cold tongue of water and this movement of water essentially disappears. And so the water's then warm, and then there's a lack of nutrients, then there's no plankton, then there's no little fish, then there's no big fish. And so the regions of South America suffer, in a sense, during these El Nino years. What I also want to mention is a couple of things with the prevailing westerlies. Notice how these arrows here at the top during our normal are much larger than the arrows down here at the bottom, right? So the size indicating the strength. And so weaker trade winds down in El Nino versus normal. And also during El Nino years, there's this other kind of circulation called the Walker circulation, but basically it allows for more storms to migrate across the Pacific Ocean and have greater implications in the central equatorial Pacific. So any book I've used for whatever reason does not freaking include having a figure of La Nina, so apologies on that. But basically La Nina would be a strengthening of the patterns that we observe in normal. So just really, really strong trade winds and much greater upwelling and much cooler surface waters on the central equatorial Pacific. So there's many impacts to weather here, and I always have to make this like super known that for the Bay Area, we are right in the middle here for whether it be El Nino or La Nina. The Bay Area of California is right in the middle in terms of how we are impacted here, okay? So generally for El Nino, we would see warmer than usual conditions in the Pacific Northwest and cooler and wetter than usual conditions in the southwest and southern United States. Whereas for La Nina, basically the opposite, where it's cooler and wetter than usual in the Pacific Northwest and wetter and drier than usual in the Southwest and the South US. And this is basically what we're seeing essentially now, except for the drier than usual in Arizona. It's actually quite wet in Arizona right now. But so this is just kind of a funny thing because people on the news will always be like, oh my God, it's an El Nino year, so we're gonna get so much more rain. It's like, no, yes, no, not really. But what we can say definitively is that El Nino, for sure, the ENSO cycle is very well known, large indicator for tropical cyclone development in the Atlantic, which is right over here, right? So because of the strong, or if we have a strong El Nino, that would mean a less active, what's it called? Atlantic season. Whereas if we have a strong La Nina, then we would have a more active, Atlantic season, and that's precisely what we saw in the 2020 hurricane season, and not so much this season because there's other factors at play, but last season as well. And last thing I want to point out here about El Nino is that it's generally not a consistent or a constant cycle, but for some reason we love to call a 3 to 7 year cycle somewhat consistent. I kind of just disagree with that personally, but that's just me. So what we're looking at here is the ENSO Index. So this is where we put together the sea surface temperatures and the surface pressure together and put a number to it and call it an index. La Nina here is indicated in blue. El Nino is indicated here in red. And I would love for you to take a few moments just to kind of look at it, see what you see, make observations. I want you to kind of think about it before I just say stuff. So think about it, maybe pause the video for a second. I know you're not going to, but I'll say it anyway. So some things that we can kind of point out here are that El Ninos tend to reach a higher peak, right? La Nina is really only reaching to about -2, whereas the El Nino is reaching at about 3, right? So it's basically just being stronger is the idea here, stronger events than La Nina. Also, we can observe that El Nino cycles tend to be much longer than that of La Nina. I will also say just for this year that or for the past couple of years, the fact that we are in a 3-year La Nina cycle is pretty rare. If for some crazy reason we're going into a 4th year, that would be like scientists would lose their freaking minds. So that's El Nino, and that also finishes up monsoons. And with that, thank you so much for listening, and I'll see you on the flippy floppy.